Hi guys, welcome back to the channel. So today we are going to be discussing about the lead code question, which is first missing positive. So we are given an array of nums and then we need to return the smallest positive integer that is not present in this particular nums. And then we must implement the algorithm which runs in big O of n time complexity, and then the space complexity should be big O of 1. So for this particular array, suppose let us take this particular example where we have 1, 2, 0, and then for this we have 1 and then we have 2, but we do not have 3. So that's why we should return 3 as our answer. And then if we take this particular example, we have 1, we do not have 2, so we'll be returning 2. And then for this we do not have 1 in this particular array, and then we need to return this particular one. So suppose let us take via brute force. Suppose I'll take the number from 1 to n, which is n is the size of the array, and then I'll check whether it is present in this array or not. If it is present, then I'm going to move to the next element. If it is not present, then I'm going to return the number which we have taken right now. So that the time complexity is going to be big of n square for this. If we try to check the array for each particular number which we take from 1 to n. Suppose can we do in a better way? Suppose if I take map where I'll have int, where I'll have number to index value or frequency. This map will store whether the index or the frequency of the elements which are present in this particular array, and then I am going to check the numbers from 1 to n. And then if suppose if we do not have any, if we do not have any one of the number present in this one of the number, then we are going to return that particular number. So this time complexity is going to be big of n log n. Why? Because we are considering the map, and then the space complexity is going to be big of n. Why? Because we are taking map as our extra space. So that will not be optimized solution for this. So for this we need to optimize it a bit more. So let us consider this particular example where I have 3 and then 10 and then 1 and then 5 and then 5. So if we take this particular example, there is no particular thing like the numbers range from 1 to n or some other things. Either it can have negative value, or it can have the numbers which are out of the range, or it can have the duplicates numbers as well. So let us consider this particular example, how we need to solve this particular example. So the approach is going to be like this. So I'm going to map the numbers to particular index, map number to number minus 1 index. So that is going to be my approach. Suppose let us take 1. For this I am going to keep 1 in 0th index, and then for 2 I am going to keep it in 1 index, and then for 3 I am going to keep it in second index, like this till if it has n, then I am going to keep it in n minus 1. Suppose this is n is the size of the array. Suppose let's say I have some out of range which is n plus 3, then where I am going to store. So suppose let's say I have n plus 3 in this particular array. So if n plus 3 is present in this particular array, then there must not exist one element which is ranging from 1 to n, right? So suppose if I take this 3, then I am going to keep n plus 3 here, and then I'll check from 0th index. Suppose if 0 plus 1 is not equal to 1, then I am going to return this particular number. So this is equal, 0 plus 1 is 1, and then 1 plus 1 is 2, and then 2 plus 1 is not equal to n plus 3. So that's why I am going to return this particular number which is 2 plus 1, which is going to be 3. So that is going to be my approach. So let us check this particular example where we have where we have this particular array. So for this I am going to write the numbers. So for this I am going to take this particular 3 into here. So I am going to keep 3 here. So and then 1 I am going to store it here. So the array is going to be like 1, and then 10 will be present here, and then 3 will be present. Then after that I am going to keep the 5 and then 5 same here as well. And then after that we are going to check 0 plus 1 is already 1, so we'll move to the next element, and then the next element is 10. That means we'll check whether this particular number is in the range from 1 to n. N is the size of the array, so it is not in the range, so we'll not do any operation on this. And then I'll check 3, it is in the range from 1 to n, and then 3 plus 2 plus 1 equal to 3, so we will not be modifying the array or will not be doing any operation. And then we'll take the 5, and then for this 5 we are going to check 3 plus 1 is not equal to 5, so we are going to map to uh, 4. Why? Because 4 plus 1 is 5. So I'll check whether this particular array, this particular index contains this particular number or not. Why? Because it can contain multiple elements as well. So it contains already 5. So we cannot do any operation. So I'll be keeping 5 here itself, and then again 5 will be present here itself. And then now I can find the minimum positive integer which is not present in this particular array. How? Let us see. So for this for this I am going to have the 1, and then for this one 0 plus 1 is 1, so this is present. And then for 10, 1 plus 1 is not equal to 10, so that's why I am going to return this particular number plus 1. So that is going to be my answer, which is not present in this particular array. So let us go through the code once. So I'll be taking the numbers from 0 to till the end of the array, and then I'll be picking the current index, and then I'll be checking whether this particular number is in the range from 1 to nums dot size. If it is in the range, then I am going to map like this. It is going to map from 1 to 0, and then 2 to 1, and then 3 to 2. That's how I am going to map. And then if it is in the range, and then one more thing I need to check is nums of index not equal to index plus 1. Suppose 0 plus 1 is equal to 1, then it is already present in this particular index where we want the array to be present, so we do not need to modify anything. So we'll move to the next condition, which is, suppose let's say we have two indexes which have the same number. Suppose let me take one example where I have 1 at this 0th index and then 1 at the second index. Now I am going to check 1 minus 1, which is 0, this particular index, whether this index contain this number or not, that is this particular number. So if it is equal, then I am not going to do any operation. If it is not equal, then only I am going to swap this particular numbers which are present in this particular array, that is this one and then this one. And then after doing all the operation, I am going to check whether nums of I not equal to I plus 1. If it is not equal to I plus 1, then we are going to say that this particular number is not present. Suppose let's say it did not fail in this particular for loop, then that means all the numbers are present in this particular array, which is from 1 to n. And then after that n plus 1 is not present. Why? Because we have only size of n, so we are going to return n plus 1 as our answer. For this, the time complexity is going to be big O of n, and then space complexity is going to be big O of 1. Why? Because we are not taking any extra space for this. Yeah, that's all for this video. Thanks for watching the video.